Hello everyone, my name is Courtney Kim and I'm going to be teaching you about the process of making structural steel as well as the raw ingredients that go into making it. So I'm going to share my screen so you guys can see my presentation. All right, so this is the process of making steel. So first we're going to start with the raw ingredients that go into making it. The first one is raw iron. Structural steel is primarily made of iron, and it is made from iron ore. Carbon is also an ingredient that is in structural steel. The primary source of carbon comes from coking coal, which is typically referenced as just coke. So it is made from ground up coal that has been sealed and baked. Structural steel has a high carbon content and it can reach up to 2.1%, although from some of the compositions I've seen, it is typically a lot lower. The high carbon provides a high strength and low ductility to the steel. Limestone is also used to remove impurities. Another key ingredient is scrap or recycled steel. The different types that are often used are shredded, which is a dense material and it is low in copper. There's also heavy metal, which are larger pieces. They're dense. It's usually cleaner, has less residuals, and it's very heavy pieces. There's also plate and structural, also known as P and S. It is typically made up of scrap from demolition buildings. It is very heavy. It is very dense, but there are higher residuals in the scrap steel for that. And then the final one is number 2. It is more just assorted metal materials. Can be anything, even like from like a bike, for example, or like a washer and dryer or something. It does have a lot higher residuals, but because of that, it is going to be a little bit cheaper. Other additives that are seen in structural steel can include, but are not limited to, manganese. Manganese is used to improve machinability, resist cracks and splits. Typically, composition is between 0.5 and 1.7%. Aluminum serves as a deoxidizer. Chromium and copper are both corrosion resistant. And silicone is also a deoxidizer. And then we already talked about the steel. So this is just like a brief overview of some of the common structural shapes, grades for different steels. So you can see that they can kind of vary a bit, and there are quite a few different elements that can be in the mix of the structural steel. So now we're going to go on to the manufacturing process. So the first step in the process is to make the iron. The iron is extracted from taconite, and it is first ground to a powder, and then it is separated out with magnets. Finally, it is formed into iron ore pellets. Once these pellets are formed, they're combined with coke, which was the heated, sealed, and baked coal, and then limestone. Once these are combined, high heated air is blasted from a blast furnace, and it is used to turn the combination of materials into molten iron. Once that's been done, then the impurities need to be removed. Impurities can include, but are not limited to, phosphate and sulfate, excessive carbon, and excessive silicon. During this process is called refinement. To do this, oxygen is blown into the molten lava. Other elements are often added in various compositions to meet the desired specifications for the steel. One of the common methods is to use the electric arc furnace. When using the electric arc furnace, there's a Scrap bucket that is loaded of a blended assortment of scrap. So the different scraps we talked about before, typically it's not just one that's used, but a combination. The furnace roof is raised, then the charge bucket is brought in and the scrap is added to the electric arc furnace. The roof is then closed into place. 3 electrodes are lowered into the furnace, passing an electric current. Heat then melts the steel scrap, and then additives are added such as lime to mix with the impurities to create a slag. Then the furnace is tilted forward and the heat is tapped. This is kind of a cool looking process. I'm going to show you guys real quick a little brief clip. All right, so this is going to be the best part. So you'll want to make sure you're watching. So as you can see, it does generate a lot of heat and lots of fire there. What is it doing? Okay, sorry about that. All right, so, okay, then come the secondary processes. So the secondary processes, it continues to do refinement, get rid of all those impurities. There's often an addition of slags and an addition of alloys. A common secondary process is to use a ladle metallurgy furnace, also referred to as an LMF. Secondary processes can also include stirring, ladle injection, and removing gases. After this is the continual casting process. For this step, a ladle of steel is poured into tundish. Then this is poured into water-cooled copper molds. The steel is then drawn through support rollers with a set of water sprays attached, and then it is cut to length with automated gas burners. Then the steel is shaped. So the steel is fed into a furnace until it is at a correct temperature. So often it goes through a set of different furnaces that are set at different temperatures until it reaches that desired amount. The steel is then squeezed between rolls until it has the desired thickness. And then it is ran through mill stand arrangements that match the shape of the desired product. So there's a bunch of different types of mill stand arrangements. So they can do like beams, rollers, different things like that. After that, there's the secondary forming process. This can include a lot of different things. Sometimes the beams need to be welded. Before welding, they'd have to be rolled or pressed. Other things that are involved would be like coating, thermal treatment, joining, pressing, drilling, machining, or riveting. And that is the process of producing structural steel shapes. And that describes how or what the different raw materials are that are involved. All right, thank you guys for watching. Bye.